So yes, now if we talk about parts of a drone, so basically here you can see there is propeller, and where the propeller motors are connected, four props, motors. I am showing the parts of a quadcopter basically. Then there is an ESC called as electronic speed control. Then we have our flight controller into picture, and the camera. If the quadcopter has camera, then we'll get the first pilot view from the camera. And obviously all of these things are taking power from it. So we should be having a power distribution panel which can actually distribute the power among all these components. Like whatever power is needed for ESC, it can actually give it to them, and not too much of power or not too less of power. So it is basically controlling all the power. So this is power distribution panel. So all of these things will be connected to power distribution panel, and with the power distribution panel, flight controller will also be connected, and we'll be getting all the navigation things out of flight controller. Okay, and also one thing is that this frame should have sufficient strength to hold the propeller momentum and additional weight for the payload. So if we assume that this is a frame, so the strength should be sufficient to hold all of the payload things, and due to the rotation of propeller, what momentum is also going to generate. So the frame should have a sufficient capability to do it. Yeah, so propeller basically it has the load lifting capacity, and it also depends on the different shapes and sizes or number of props. Okay, so they are I am just showing you different kind of props. So it is called 2, 3, 4, 5, 6 by props. So it basically depends on the payload capacity, how much payload are we going to carry, or how much of the weight is of the total quadcopter. So according to that we choose the propeller. So 2 and 3 size are for smaller props, and 6 size is for the bigger prop. So long props are basically for heavy loads, and short props are to carry fewer loads, like to carry minimalistic loads. So whenever we are designing any quadcopter, we have to keep into account of all these things. So next component is motor. Yeah, so I think you guys have a decent background to understand about brush motor and brushless motor. So there can be two kind of motors, and that is up to us. That is up to the application of quadcopter to decide which motor to use. So for small size drones, they are brush motors, and for powerful or energy efficient drones, they are brushless motors. But they need ESC. ESC is electronic speed controller to control their speed. So as you can see here, first prop is connected with motor, and then motors are connected with ESC, and then the power is coming from power distribution board, and the signals are coming from flight controllers. So this is how connections are made for brushless motors. So ESC is needed for power for a prop to run, or for a motor to run. So yeah, so here in ESC, it basically connects battery to motor for power supply, as I explained. And so there are some signals coming out of flight controller. So suppose there is a path which we have, which a UAV has to follow. Now flight controller will decide how much to turn, or how much like which are uh, we have to take a 2-degree turn in the pitch direction or roll direction. So it will give the command accordingly, but ESC will convert these signals to RPM, because motor only accept the RPM command, right? Motor can only turn with 1000 per minute. So ESC just takes in the command from flight controller, converts these signals into RPM, and therefore motor can run, and we can props can run, and we the quadcopter can take off. Okay. Yes, so next are payloads. We are keep saying about payloads and all. So basically it is the carrying capacity of the aircraft, and it is measured in terms of weight, kgs or pounds, etc. Because now when we talk about lift, it has to overcome the weight of the aircraft. So this weight will involve the full body of the quadcopter plus the payload which it is having. So the lift force is calculated by adding up all these forces. So it should be more than that to lift off. Okay, so according to that, we have to choose propellers and motors and all of these things. So payloads can be a stationary video camera, or a camera with gyro specialization, basically gimbal camera with which has pan and tilt movement. Then high power radar it can have. And then if it is a delivering drone, it can have goods like whatever we has to deliver. So it depends on the use case. And again, weapons, if there is a use case of that armed drones and all. So these things can be different payloads for a drone. It needs to be taken account while designing or while selecting a quadcopter motor. And then the main part is the flight controller. It is called as the brain of the UAV. It is doing all the calculations. So basically, if there are no sensors, then commands will be coming via joystick from the captain that it is moving here, moving there, and all those things. If there are sensors, then it is taking sensor data into account. And then as an output, it controls motors for drone navigation. So it like basically the signals goes to ESC in brushless motors so that motors can navigate. So flight controller is doing all the things inside, doing all the calculation inside. If we have to follow a path, flight control will tell where to tilt, what should be the orientation. Well, getting the signals from all the sensors. And sensors are always GPS, accelerometer, gyroscope, magnetometer, compass, camera can also work as a sensor. So all those are examples of sensors. So yeah, coming to sensors. So basically, there is gyroscope, which determine orientation of the vehicle. And then there is GPS, determine position, basically latitude and longitude of the vehicle. So it is determining position of the vehicle with respect to the global position. Then we have accelerometer, which measures acceleration, and hence we get the velocity out of it, velocity of the aircraft. Then we have barometer to determine altitude. The altitude will be obviously mean sea level altitude, not the above ground level altitude. But since we have a baseline, so we can, if we want to calculate above ground altitude, we have to take a reading in the beginning. Suppose the reading is X. Suppose in Bangalore, normally our ground level is 700 meters, 700 to 800 meters. Okay, so we just took the reading at the very first instance that the altitude is 700 meters, and then as and when UAV is flying, we are getting one altitude, but that is mean sea level altitude. Okay, so suppose the altitude is saying it's 1,000, but from the ground it's not 1,000, it's 1,000 minus 700 because our ground level is uh, itself is 300 700 meters. So now from the ground, UAV is 300, which is 1,000 minus 700 meters. So UAV's above ground level height is 300 meters. So which again gets calculated using barometer or fusion data between barometer and GPS. And yes, talking about sensors, we have radar, and camera for LiDAR and all for obstacle detection, camera for imaging. And there are other sensors like compass or magnetometer to find out the heading of the UAV or the orientation or position of the UAV. So here we are at one more interesting fact about the UAV. I hope you guys have heard about Boat Lab Dynamics. So I think it is a startup from IIT Delhi. So it has hosted second largest drone show of the world with 35 drones taking to the skies above Rashtrapati Bhavan during G20 summit. And you can actually see the symbol is made up by 3,500 drones. So, and since it was a second largest drone show involving 3,500 drones, so it was a like very big achievement or very big news for our company. So basically, Boat Lab Dynamics work in this direction where they host drone shows in different for government or for personal use cases and all. You can actually go to the website and check out like it's really interesting the shows they have done. Okay. Yeah, so till now we have discussed about the UAV, totally UAV, like what parts are there inside a UAV, how it works, what is the working principle of the UAV. But now we'll discuss how it communicates via ground, how we get the information of position or orientation of the UAV from the ground. Because since we have discussed about the autonomy level, so there are 0, 1, 2, 3 autonomy where we need to have the information about drone in on the ground. It needs to be there so that pilot can take control whenever needed. So how the communication happens, that we are going to see. So yeah, this is UAS communication. So we have our unmanned vehicle. So basically, this illustration shows the communication links between ground station. Here's the ground station, the airports or our air traffic controller, the satellite, and UAV. Okay, so UAV can communicate with the ground control station. We have a ground control station, so UAV will be having the transmitter, and via receiver we will receive the signal and will get to know the information about UAV in the GCS if it is in the line of sight. So basically, if the antenna can trace the UAV, if it is beyond line of sight, there is no way that we can get the information in ground control station, but there will be satellites which are tracking it. So for beyond line of sight, we control it via, or we get the information via satellites. And then there is air traffic controller communication services, which are also available, which these services are also communicating with the UAV. And it depends on what kind of UAVs are there. Okay. So for every UAV, there is no direct communication with ATC. But if UAV is for purpose under government used, they will be communicating via ATC communication services. And from ATC, there is again a ground connectivity. So if it is out of line of sight with the ground control station, we'll get the information from ATC. Okay, in all these ways, we are getting the information about UAV's position or UAV's, like whether UAV is fine or not. Like we are getting that information to ground control station, and if pilot needs to take control, it can, he or she can take control. Yeah. So yeah, for the navigation system, basically there is a fusion happening between GPS, a global positioning system, and INS. INS is basically inertial navigation system. It provides the altitude information. So why INS is needed? Because we get altitude information from GPS, right? But there is a cache here. So while GPS services a seamless navigation with a cheap receiver, it may not receive a satellite signal by the obstacle or signal jamming, or if it is if UAV is inside some area inside the room and all, we normally do not get GPS signal. So like it might have happened with you also, like we are in a remote area, village area, or we are in a jungle kind of thing where we do not get GPS signal, but UAV is supposed to fly there, right? Like there is one of the application to fly inside a tree, like in for agricultural well-being. There's one application for that. So there INS plays a role. So it gets the altitude information. So that is why we are saying that there's a fusion happening between GPS and INS. So whenever GPS data is available, the fusion will be there, which estimates the altitude and which will be far more correct altitude rather than only taking GPS altitude. And then if there is no GPS data, then INS will does its own calculation and give us the altitude value. Okay. And yes, so there will be a receiver in the aircraft as well to respond to the radar scanner emitting from the ground control station. And if the aircraft carries a camera, it will give the live feed to ground control station. So communication is happening both the ways. Aircraft is having a receiver as well to communicate, like to receive the data from ground control station. And again, ground control station is also having communicating with that. So it is a two-way communication. So there are two roles of ground control station. One is to control the drone. If autonomy level is not level 4, then obviously it has to control the drone. So here it's not like pilot is sitting with joystick and controlling the drone. So in autonomy level 3 and 4, we can give the commands using flight path, right? So these commands we give in ground control station. So it is basically controlling the drone. And the second thing is whatever data is coming out of UAV, it is processing that data, and then whatever like application wise, it is segregating that data and making use of it. So uh, these are the two main functionality of our ground control station. Talking about communication, obviously we have to talk about data link. Okay, so UAV to ground control station is the like there is a data link which connects both of them. It allows communication and enables the data transfer between a UAV and ground station. So since there is a two-way communication, there is an uplink and there is a downlink. So uplink is GCS to UAV. So it basically transfer flight path angle or real-time control commands. So like flight path, it can also change the flight path according to UAV behavior, or if like it sees that UAV battery is very less, then it can modify the flight path and ask UAV to land, right? So the commands are going from ground control station to UAV. This is uplink. And there's one more thing called downlink, where the commands are going from aircraft to ground control station. So here aircraft is sending its positional data and then camera feed. So this information is being received by our ground control station. Along with that, it sends its housekeeping data like fuel state, if it is run by fuel. Otherwise, battery percentage, how much battery is remaining. So that information, or engine temperature if there is an engine. So that information gets propagated via downlink. Okay. And in the previous slide, the same thing I have described that uh, there can be two types, or rather three types. Now there are three types. So one is line of sight. So this line of sight uses different frequency bands, and it needs two unit, drone and ground control station, with antennas, and it allows point to point high speed communication. Okay. But if it is beyond line of sight, it comes under BLOS. So here in BLOS is uses satellite links. So like links are usually made at microwave frequencies, since we are using satellite data, and like the communication distances is greater than line of sight. And then there is one more thing called technical data communication. So like it is simultaneous communication and includes secure data transfer features among like other capabilities. So it requires lower bandwidth than other data links. So that is why people are preferring this nowadays. So it combines both of them, and it also requires lower bandwidth frequency. But like if I talk about one of the biggest challenge for UAV, it's like generally data links suffer from power attenuation or Doppler effect, which affects the spectral efficiency, and from many losses due to the channel characteristics. There are important, like basically there are many important requirements for this type of links, such as long distance and high speed. So that is why designing data links for UAV is much more challenging than designing other wireless link. So this is one of the biggest challenge to design a proper link. There should be a proper communication with all the systems. So yeah, so that is also an open area where most of the researches are taking place. Yeah, so till now the paths have been discussed, and also about the communication, the ground communication, data link communication, and navigation has been covered. So any questions? I'll just wait for it if you guys have any questions till now. Okay, great. Yeah, somebody wants to speak anything?
Ma'am, about this data link right now, there was ma'am talked about the issues that we are facing currently. That
Mm-hmm.
is signal attenuation, and that is basically like we have difficulty communicating with UAVs at a long distance. So, the advanced telecommunication industry of like having a
Mm-hmm.
designation of telecommunication standards 5G, um, is does those like those standards, do they apply for UAVs and communication? I mean, like advancements in telecommunication, can that be used for this as well, or like would that help here?
Yes, that's a great question. Yeah, obviously. So now 5G is coming into picture. So now people are actually has started using it. So yes, it has already started to using 5G in the drone industry as well. So yeah, it will overcome these kind of challenges. But still, there is no practical proof of it. It's still in the development phase. So yes, these communication protocol will actually help in the data link. Uh,
Yeah, ma'am. So like nobody has actually applied this, or like
no, no. No, people are actually doing it. There are many industries who are applying 5G. I'm not sure in India, but Israel specifically, they are using the technology. Um,
Oh,
yeah.
oh, perfect. Thank you.
Okay, no problem. Thanks for the question. Anybody else? Okay. Okay, I'll take it as a no. I'll just go ahead. Yeah.